Dear learners, I am Dr.D.Rajamani, Assistant Professor of Chemistry, the Standard Fireworks Rajaratnam College for Women, Sivahasi. In this model, I am going to explain the topic Electronic Configuration of Atoms under the title General Chemistry 1. First, we can see the course outcome of this model. By studying this electronic configuration of atoms, the learner can able to describe how the electrons are distributed in their atomic orbital. Next, they can got insight about the number and composition of various atomic orbitals. From all these points, some lay down in the structure of all the matter can be obtained. Now we can see the electronic configuration of atoms. The electronic configuration of atoms going to explain about the arrangement or distribution of electrons in various cells, subcells and orbitals of an atom. If it is restricted to various subcells and orbitals of valence cell or outermost shell, this can have the name as valence shell electronic configuration. Now we can see the representation for the electronic configuration of atoms. This notation going to represent how we have to write the electronic configuration of an atom. N L power x. Here the left side, N which is present in the left side is going to be principal quantum number, and this N value going to describe the cell number where the electron is going to be located. Next comes L. The symbol L represent the azimuthal quantum number, and it is going to represent the subcell where the particular electron is going to be located, and the superscript X going to denote the number of electrons which is going to be present in the particular orbital. The type of cell is going to be decided by the value of L. If the L value is going to be 0, the type of subcell is going to be S. For L is equal to 1, the type of subcell is going to be P, and for 2 the subcell is D, and for 3 the subcell is F. Let us see one example, 3P2. Here the 3 value represents that the N value is going to be 3, and it is going to describe the cell number, and the P orbital is going to be because of the L value 1, and the number of electrons going to be present in this 3p orbital is 2. In writing the electronic configuration of atoms, we have to follow some rules and principles. These rules and principles going to help the learners how to write the particular electronic configuration in a particular orbital. Before writing the electronic configurations, we have to know what is the maximum number of electrons that can be accommodated in a cell as well as in a subcell. The capacity of a particular cell is going to be represented by the formula 2n square. So here n is again number of cells, that is it is going to represent the principal quantum number. By calculating this 2n squared value, we can find out what is the maximum number of electrons going to be present in the particular cell. If you take the first cell, the n value is going to be 1. So when you apply this 2n squared formula, the maximum number of electrons that can be occupied in the first cell is 2. For the second cell, the maximum number of electrons that can be occupied is 8, and for the third cell the value is going to be 18, and finally for the fourth cell it is going to be 24. So applying this 2n squared formula, we can find out what is the maximum number of electrons that can be occupied in a particular cell. Next, we can see how we can calculate maximum number of electrons that can be located in a subcell. For this, we are going to use a formula 2 into 2L plus 1. Here again, L is the azimuthal quantum number and its value is going to start from 0 and it is going to be continued as 1, 2, 3, etc. If the value of L is 0, automatically the subcell is going to be S, and when you apply this 2 into 2L plus 1 formula, the maximum number of electrons that can be occupied in the s orbital is going to be 2. And for p orbital with the L value 1, the maximum number of electrons are going to be 6, and for d orbital it is 10, and for the f orbital 14. So we can automatically find out how many number of electrons can be occupied in a particular subcell using this 2 into 2L plus 1 formula. Next, we can see how certain principles going to help the learners to write the electronic configuration. The first important one is the alpha principle. Alpha is a German word and the meaning of the word is sequence or build, or we can also have the meaning as construct. So alpha principle going to have another name also. They can be called by the name sequence principle or construction principle. Why they are called as a sequence principle is they are going to tell us the sequence in which the electrons are going to be filled in the particular orbitals. According to the alpha principle, the orbitals are filled with electrons in the increasing order of their energy. So the orbitals with lower or minimum energy are going to be filled up first, and then the orbitals with higher energy going to start to fill with the electrons. So this is called as a sequence. So the electrons are going to fill from the lowest or minimum energy level to the higher energy level. The N plus L rule going to give additional support for the alpha principle. When you calculate the N plus L value, that is going to be related to the energy of the particular orbital. So the orbitals which are having the lowest value of N plus L will have lower energy and they are going to be filled first with the electrons. When two or more orbitals have the same value of N plus L, in that situation we have to consider the N value. We have to compare the N value of this two or more orbitals and the N value for which, that is the orbital with a lower value of N going to filled up first, then the highest N value going to be filled up. So this image going to represent the pattern by which the electrons are going to be filled up in the various orbitals by following the N plus L values. So by increasing the N plus L value, the occupation of this electrons also represented or occupied in the various atomic orbitals. Next comes Pauli exclusion principle. This Pauli exclusion principle not only very helpful to write the electronic configuration of a particular atom. By studying this Pauli exclusion principle, we can also understand the structure as well as properties of various matters. The Pauli exclusion principle is going to explain the stability of various materials also. So it is a very important principle. According to this Pauli exclusion principle, no two electrons have same or identical quantum numbers. So what are the quantum numbers we are going to compare here is N, L, M and S. Here N represents a principal quantum number, L represents the azimuthal quantum number, M is a magnetic quantum number and S is a spin quantum number. Let us explain this Pauli exclusion principle by taking helium as an example. We are going to consider the two electrons which are going to be present in the 1s atomic orbital of helium atom. We are going to find out what is their quantum number values, various quantum number values. Since it is a 1s atomic orbital, the n value is going to be 1, and for s subcell the L value is going to be 0, and accordingly the magnetic quantum number value is going to be 0. So for both the electrons, the N, L and M values are going to be same. But if we come to the spin quantum number, one electron is going to have the plus half value and other one is going to have the minus half value. That is, they are present in the anti-parallel position. So if three quantum numbers are same, at least they will differ in their spin quantum number. That is the essence of this Pauli exclusion principle. And why we are giving exclusion in this principle is, this principle going to prevent the electrons from occupying the same energy level with same set of quantum numbers. So that it is having a special name as exclusion. Next comes Hund's rule of maximum multiplicity. This Hund's rule going to explain the electronic configuration of same energy levels. Sometimes same energy levels going to possess degenerate orbitals. So we will have confusion where the electron is going to be located first, whether they are going to enter into this degenerate orbitals singly or the pairing is going to be takes place. So this confusion is going to be revealed by the Hund's rule of maximum multiplicity. According to this Hund's rule, electron pairing in p, d and f orbitals cannot occur until each orbital of a given subcell contains one electron each or is singly occupied. This Hund's rule is particularly applied to the degenerate orbitals. Here p, d and f orbitals come under the category of degenerate orbitals. The various types of p orbitals are px, py, pz, and 5 types of d orbitals are available. They are dxy, dxz, dyz, dx square and dx square minus y square. Let us illustrate this Hund's rule by taking some examples. First, we can take the nitrogen atom. The electronic configuration of this nitrogen atom is 1s2, 2s2, 2px1, 2py1, 2pz1. Here 1s2 and 2s2 orbitals are not going to be degenerate orbitals. So we have to focus on p orbital only. P orbital going to consist of 3 electrons. Here the 3 electrons are going to be singly filled in the px, py and pz orbitals. Here first singly filled nature is going to be happen. There is no pairing going to happen here first. Next we can take the oxygen atom. The electronic configuration of this oxygen atom is going to be 1s2, 2s2, 2px2, 2py1 and 2pz1. Here we can easily explain the Hund's rule. Since we are having 4 electrons in this p orbitals, first they occupy the px, py, pz singly, then only the pairing going to start from the 2px orbital. So the Hund's rule going to tells us in the degenerate orbitals how the electrons going to enter or how they are going to fill in the particular orbitals. So now we using the various principles we have learnt how to write the electronic configurations. These alpha principle, Hund's rule and Pauli exclusion principle, they govern the overall electronic configuration of atoms in the periodic table. So by following the alpha principle, we can explain that the lowest energy orbital will be filled first. By following the Pauli exclusion principle, we can have an idea that no two electrons in the same orbital can have the same spin. And Hund's rule is very helpful to decide the electronic configuration of orbitals in the same subcell. So I think you have learned how to write the electronic configuration of atoms. Thank you.